I think it's readable.
Oh, yeah, I think it's better.
Maybe just
Riuscite a leggere?
Ok, ciao a tutti, grazie per essere qua, il mio italiano non è buono, so la talk is going to be in English, but I just wanted to say hello for being here and not having an aperitivo because it's a really sunny day, so thanks for coming. My talk is called From Source Code to Kubernetes, a continuous deployment tale. And I call it a tale because what I'm going to do is explain all the process since you have your source code in GitHub or Bitbucket or whatever you use, and you end up with it in Kubernetes. So let's start with it. Who am I? I am Alex, or González Rodríguez. I don't really like that much this kind of slides, but I think that it's important because I work in a bank in Spain and I work in the platform as a service team. So when during this talk I talk about I talk about what we are doing on the bank or how we are doing it there. I was living in Milan actually for 1 year and my Italian is still as bad as the first day. Sorry about that. So what's CI? Who here knows what continuous integration is? Okay, a lot of hands. I was expecting that. And who is using it? Well, not that much. I was actually expecting more. So, continuous integration is the process that you use after you push your code to your repo, and you make sure that your code is correct. Actually, Fabrizio, where is Fabrizio? With Z, not Z. Yes, Fabrizio. Excuse me. Was showing a proper example of this, like when you create a pull request in Kubernetes, you will see a lot of green ticks, and all these green ticks is what we are going to be doing with continuous integration. So these steps are just some examples for a simple one, but ready to production, to be honest, if you want to use it. So you do a push on Git or whatever you're using as a repository for you, and this standard is like a webhook. It's basically an HTTP call from the repo to the square, which is our CI tool. Our CI tool can be whatever, okay? It can be Jenkins, it can be Travis, we are using Compass as well, PostShip, Circle CI, you have a lot of options there. I don't really care about the tool. The important thing is the process. So in this case, what I'm showing is we are talking about a Go tool. So the first thing we do when we push is running Go generate, which is going to be running for example, the generation of gRPC clients, or it's going to be running the generation of documentation. And then we run a validate step. These validate steps, if you are familiarized with Go, how many people uses Go here? Okay, cool. So Go, when you have a tool which is called Go imports, that a part of importing the things that you are using and removing the things that you are not using is going to be doing formatting for you. So when you see a piece of code in Go, it's usually more or less the same for everybody. And it's because we run this kind of tools. So if you forgot to run it locally, when you push it, it's going to check it. You have Go bet, or maybe you have something more clever like a static analysis with Sonar. We are using that. Then you run Go build. Go is a compiler language, so the fact that it compiles is good, but it doesn't really mean that it's working as expected, okay? You know that it's grammarly correct, but this doesn't really mean anything. And then you run the test. That can be unit test, integration test, end-to-end test, smoke test, whatever. If everything is okay, you are going to get a green tick in your continuous integration tool. So what is continuous delivery and continuous deployment? Not a lot of people was using continuous integration here. Anybody is doing continuous deployment? Nice. So we are doing continuous deployment as well, but not for all environments. We are in a bank and we move money, so we just do continuous integration in the P environment, so in staging, okay? The difference between continuous delivery and continuous deployment is that in continuous delivery, you are going to end up with an artifact that you can deploy if you want. Maybe you have a manual process for it. And in continuous deployment, you get this artifact and you deploy it to some environment. It can be, as I say, production, or it can be other things. Let me get this. So the process, maybe you cannot see this for the colors, but the process here is more or less the same, okay? You do a push or a merge. This usually happens when you merge to master. And you have a webhook that is going to be calling your CI tool, and you do all the steps that we were doing before, and some extra more. In this case, we create an artifact that, for the sake of this of the demo that we are going to have later, is going to be a Docker image. And we do some security checks on it. You have some tools for it, maybe Claire, maybe Atomic Scan. In the bank, we are using some internal tools for that. And when we have the seal of approval from security, is at the moment that we decide to deploy, okay? So I say seal of approval of security, but really it's the seal of approval of all this process. I was checking a lot of things. So now that we have that clear, let's start with the tale. So once upon a time, there was a guy that was called Princess Gumball. I don't know if you like Adventure Time. I do it. If you don't realize about it, you can maybe call him Go. Okay, for the sake of this example. So the first thing that we are going to be doing is creating a small example that we are going to be deploying later. This example is just an HTTP server that is going to show a message. So this is our main.go. We have a message. We write this message to the response. This is usually how you deal with the request response in Golang. You have a function that is going to get a request, and you have a response where you can write. In this case, we are writing the message hi buffer.com. Then we have a router. If you are familiarized with Go, you are going to be surprised that I am using Gorilla MOOCs here, because we can do this without any library at all. But the important thing for me is to have at least one dependency to have an example that is closer to real life, okay? Because we are going to be installing this dependency that we don't need, but it's nice to see how we install dependencies. So if we go to slash, we are going to be serving that request with this handler, which is just going to write the message. We have some configuration. In this case, we have the port by default, which is 881. If we set up the environment variable port following the 12-factor applications or cloud native apps, you are going to change the configuration for the port, and you can be listening in other port. And that's maybe it. We listen on serve, which means like, okay, spin up the server for me. So if we are in our machine and we want to make this work, we run go build, which is going to create a binary, and this binary is going to be, remember we are in the context of our machine, this binary is going to be in your machine, okay? If you run go test dot, you are going to be running the test. Later on I will show you the test that I have for this. It's pretty simple, but it tests something, so we can get our build in red state, so it's not going to deploy anything. So more characters here. There is Princess Bubblegum, but I prefer to call her Docker. Docker is a project and a company that started in the States something like 6 or 7 years ago. It kind of made the containers famous, no? So the thing is that with one kernel that have support for namespaces and C groups, you can have different user namespaces in top of it. What does it mean? Like, instead of having the virtual machine that have the kernel and the user namespace, you can share the layer in the bottom, and you can have in the top, for example, a Fedora or an Ubuntu or an Alpine that we have here. We have more advantages about using Docker, and we are going to be showing them now. So the thing is, we are going to create a Docker image, and this Docker image, you can push it to some registries. Like when you create code and you push it to GitHub, with Docker you can create images and you push it to hub.docker.com or to your own registry. You have a lot of tools for that. So to create a Docker image, you need something like a manifest. A manifest is no more than the steps that you need to end up with this with a working Docker image. So in this case, we are saying that we are going to be using Golang 1.10 based on Alpine 3.7. The first bit is the name of the image that you are using. In this case, it doesn't have a prefix, so it means that it is one provided by Docker itself. If it has a prefix, maybe you are downloading mine, and maybe I am adding some backdoor there or something, and you don't know that. Okay. In the bank, of course, we are not using that. We are using our hardened ones. But this is good enough, okay? You can actually go to the GitHub repo and see how it's built. We're using version 1.10 Flow, and as I say, Alpine. Alpine is a really small distribution for containers. Can you see it in the bottom? Or yeah, cool. Alpine is a really small distribution for containers. I think that now it weighs something like 3 megabytes, and in 3 megabytes you have a little bit of tooling, and the most important thing, which is a package manager in case that you install something. So you can get Alpine with 3 megabytes and then run APT and install Beam inside this container, and you are going to have Beam in 3 megabytes. So the next step is this word clear magic. If you usually work with Go, you know the mess that is about the Go path and all that. So forget about that. This is just where we are going to be putting our code to be able to compile it, okay? But this is the important bit. We are installing dep. Dep is a dependency manager for Go. There are a lot of versions, so there are a lot of tools for that. We, for example, use Glide. I know that Vigo is there, but there is a lot of controversy about it. So I think that dep was kind of hawkish in terms of the people that like it and dislike it. It's the most famous now. So first thing that we do with dep is copy the go package.log and go package.toml, which are the files where you specify that we are going to be needing MOOCs, which was the project or the library that I was showing before. Okay. So after we have the dependencies that we need, we make sure that we install them. And then after we have that, we add our code. And now you say like, why you are adding your code before installing the dependencies? Why you don't do everything on this step? So one of the important things of Docker is that it works with layers. So each layer has a hash, and if the layer didn't change, you are not going to be running it again. So if the dependencies didn't change, which is kind of common because you don't install dependencies all the day, but you change the code all the days. So if this didn't change, this step is not going to be run, so it means that you are not going to go to the internet and download the dependencies again. Correct. I am showing you this for Go, but it's actually the same, for example, on Python with the requirements.txt, or on Ruby with some other dependencies. Okay. It's usually the same. You copy the minimal thing we need to install the dependencies, and then you copy your code. And then we run go build. We are running go build, but we are running go build inside this container. So we are going to end up with a binary, but we are going to be ending up with a binary inside this container, not in our machine. Okay, this is really important now. Why? Because we are going to be using the multi-stage build. Multi-stage build in Docker means that instead of having just one manifest, you have several manifests one after the other, and the last one is the one that is going to create the image for you. So we were using one manifest to creating an image that has Go and all the tools we need to compile, and then after we have the binary, which is the only important thing we need, we are going to be copying it to other image. So we say like from the builder, you get this go ssc.github.com buffer.com, which is the binary, and you copy it inside this container. And now is when we say at runtime, when you run this container, what you are going to be running, this binary that I just copied. So when we run these steps, the first one is for doing Docker build. It's going to play the first stage, installing all the dependencies and compiling your code, and the second stage with the binary, and this second stage is the artifact that you are going to be creating with this, okay? And then you can run Docker run, and you are going to be running the service inside a container. Nice. Do you remember Gumball actually call Go and Bubblegum actually call Docker? So they wanted to live together in this beautiful castle, no? Kubernetes, or whatever you prefer to say. So, well, let's go back actually. Kubernetes is an orchestrator for containers. How many people is using here Kubernetes? Okay? Well, nice. So, having an image with Docker and run this image is nice because you don't need to deal with all these dependencies and all that. But how do you deploy that? You go to Amazon, you create an EC2 instance, you copy the Docker image, and you run it. And what happens if the Docker image goes down? Or what happens if the instance goes down? Or what happens if you need to scale? So Kubernetes is going to deal with all that for you, okay? Basically, when you start with Docker, you do all this orchestration by hand with a lot of bash scripts. At least is how I did it. If you didn't do it like that, you are lying. And with Kubernetes, you don't need to deal with all that, okay? But you need to deal with YAMLs. So you have a lot of different ways of deploying things in Kubernetes. But YAMLs is the most basic one and is good enough for this example, okay? Probably if you are running Kubernetes in production, you are running it with Helm, or you are deploying literally with the API or something like that. What we do, we have an API in the middle, which is our middleware, and we deploy literally with the API. Kubernetes have a lot of interesting resources inside it. The first one is the pod. Pod is the minimal thing that you can run in Kubernetes. What's the difference between a pod and a container? So a pod can have one or several containers inside. If they have more than one container inside the pod, they are going to share the lifecycle, they are going to share localhost, they are probably going to share the volumes as well. And this is really important when you follow some patterns like, for example, the sidecar container. It's really interesting for service meshes when you have a proxy around your application and you are using that for the mesh. Or imagine that you want to have a container for transforming your logs. You can have one standard one to transform the logs, and you can put it just at the side of the container running your application. And in case that one of them goes down, this is going to fix it for you. Other sources in Kubernetes have the same schema. They have you define the IP version, you have a kind, you have metadata. In this case, we just say that name is just a pod, but it's a key value. You can store there whatever you want, and then you have a spec. All of them are the same, okay? When you are getting it, you have the metadata, the spec, and the status as well. The status is the things that change inside the cluster. So in this case, we are just going to be getting the image that we were using before, and we are going to run it inside Kubernetes, okay? So we say containers, remember in plural, not singular. We have one with the name GopherCon, and this is the image that is going to be used. So if we run this, I don't know if you see this there at the end, but it's like kubectl apply and the name of the YAML. So imagine that all the white screen is our cluster. This is what we are going to have inside our cluster, okay? We are going to have just a pod there. If it goes down, nobody's going to take care of it. Because we need this. We need a deployment. A deployment usually works like with a current state and a desired state. So at the time that you were creating the pod, you were not defining any desired state. You were just saying like, I want to run this pod. But in the case of the deployment, it's different. It's going to be reactive. You say like, I want two copies of this pod running, and then the current state will see that there is no copies of this pod running, and it's going to make the difference. Say like, okay, I need to run these two more copies, and it's going to do it for you. If they go down, it's the same, okay? So we have metadata. In this case, we are adding a little bit more of metadata, which is the labels. So in Kubernetes, you are running cattle, not pets. So you don't really give a name to what you are running inside. You try to tag it in a way that you can query for it later, okay? So in this case, I'm just saying that my app is GopherCon, but probably you want to say like, my version is version 1, and the tire is backend, and so on, so on. It's completely open. So the spec that I was saying before, you have two replicas of whatever is on this template, okay? And on this template is the pod that I was showing before. It's a little bit difficult to see like this, but in the documentation you can see the examples, and it's more or less easy to follow if you copy and paste. I will not lie to you. You need to copy and paste it because it's really easy to forget. So on the template, this is actually the same on the pod, okay? In case that this current state and desired state doesn't match, it's going to get the template and create one for you. So if we run this, we have 2 copies of our GopherCon application. This is our cluster, and the 2 copies are there. But if one of the applications goes down, you are going to be able to create, no, Kubernetes is going to create it for you, okay? It's really nice, but this is the current state. So we have people trying to get into our application, maybe my mother, or my father, or Hacker News, who knows? But they cannot do it, because the context here, the red square is our Kubernetes cluster, and we are not exposing the service. So if we want to remove this wall, what we need to do is create a service. Service is the way to expose whatever is running inside your Kubernetes, inside your cluster, to the real world. So it's the same metadata and a spec. And the spec, we are saying that this is a type load balancer. You have different kind of types, like cluster IP or node IP, but the important one, for our example, is this, which, for example, in AWS is going to create an elastic load balancer for you. Or in Google, the same load balancer as a service that they have is going to create one for you and configure it as we say now. Which is, okay, I want to expose the port 80, and it's targeting this port inside the cluster, 881, which is, if you remember, the default one for our application. But you are not saying, I want to target this pod and this pod. You are saying that I want to select the pods that that have this port listening by labels. In this case, app GopherCon. Maybe if you are in production, you want something more complex than this. So with that, we remove the wall and the people can get in. Okay, so now all these steps were really cool, but doing it by hand every time that you want to do a deploy is a little bit error prone and all that. So we are going to be using the continuous integration and continuous deployment processes that we were explaining before, and we are going to be doing it. So demo time. For the sake of the example, because I didn't want to wait for it, I have a cluster already created on Google Cloud Engine with 3 or 5 nodes, preemptive machines, pretty cheap. I have Jenkins installed, but I install Jenkins not by hand. I install Jenkins, and you will see it in the repo that I am going to share with you later. I install Jenkins with Helm. Helm, as I told you before, is the package manager for Kubernetes. In case that you want to install any other application, it is kind of famous. It's going to be there probably. And what else do I have? Oh yeah, and on Jenkins I have the credentials to access to my hub.docker.com, so I can push my images. Okay. So let's go for the demo. Maybe I will move here. So I'm sorry for using Jenkins, but this is what we use at the bank. It's familiar for me, it's a little bit ugly, but at the end of the day it's just a tool, okay? If you want to use whatever other tool, I don't really care. It's, the important thing is the process. So,
Zoom.
Can you just make
sorry about it. Okay. So the only thing that I did was logging, okay? Can you see it now? In the bottom? Okay, the only thing I did was logging. I have still my GopherCon. I don't want it. I will delete it, sorry. This is the previous one, because I was so nervous on testing it time to time. So I hope it works. So let's create a new pipeline, okay? We're going to call it GopherCon as well. It's just a pipeline. It's a GitHub project, and the URL for GitHub, I'm going to share this URL with you later, okay? It's just this one, González GopherCon. What we want is when the GitHub hook pings Jenkins to be able to build this code that we have here. And the other important step here is that we are getting the pipeline from Git as well. What does it mean? It means that your Jenkins definition or the steps that you are running inside Jenkins, you don't write them in Jenkins, you write them in your source control. So in case that you change something, it's going to be tracked there, okay? We save this, and we build it. You see? So I'm doing the first build by hand, okay? In the meantime, I wanted to show you, oh, I have it over here. The only thing that I changed on GitHub, okay? So on GitHub, if you go to settings, you go to webhooks, and this is the GitHub. This is the GitHub webhook for Jenkins. This IP is my Jenkins instance. You are sending application. The secret is just the username and password, okay? And I don't want to take the webhook because it didn't change. So let's see if this works. Okay. So this is doing some steps now, okay? Because I click on it before showing you how the hook works. The Jenkins file is this one. The first lines, I don't want you to see those because it's just configuration. Like the only thing that it's saying is that they want a Docker to be able to run my tests inside Docker, and the other one is saying that they need another pod that has kubectl available, so I can use kubectl to do the deployment. But the important bits are this one, okay? You get the last version of your of the branch that you are testing. I don't know if you hear me when I look to the screen. The second step is the test. So we are running Docker build, but just for the first part of the Docker file, because I need Go to be able to run Go test. Okay. The second part, the one that has the binary, didn't have Go, so it's not good enough for me. But it's good enough here. Okay. Here I am building the full image, and I am pushing it to my González Gopher.com. And then we run with kubectl the same YAMLs that I was showing to you before. We are running them here, and we change the image to be using the last one. I am using short commit as the version name. Okay, short commit is something like 6 hexadecimal numbers from the commit. Okay, so if we see this, we are in red because my test, a simple test that I did, was failing. It was expecting high Kubernetes from Milano, and it got high wall. So if you go to the dashboard, you are going to see that your build is red. And if you want to configure Jenkins, you can tell Jenkins to write to GitHub that the build failed. Okay. So now we are going to fix it. This was the test. I don't need to change anything on the test. Okay, the test, the only thing that does is doing a request and checking that the messages are equal, and if not, it fails. So this was failing because instead writing the message, I was writing high wall. That's it, the only change I need to do, okay? So now I have this change, they write the message. We can actually test it locally, but it's not that important. Well, it's not that important on the demo. Please test locally before pushing. Git add main, git. Actually, let's change the message because maybe you don't trust me, okay? So instead, hi Kubernetes from Milano, it is, what time is it?
I'm not sure.
9 p.m., okay. And where? So, yeah, you can use Mokis on Go, that's completely okay. Don't do this at home either. I am writing a commit message with work in progress, and we push this.
Don't try this at home.
Yeah. So now that we push, if everything works as expected, yeah. So we get a pending build here. It's probably going to be run. It's probably running, but it didn't refresh. Okay, so yeah, it's running after a refresh. You see the console output. The steps are going to be the same. One important thing about these steps is that the part that I am using for the testing, the Docker build, is going to be reused for the final build, okay? Because the layers didn't change, so we can reuse them without building them again. So now just bear with me that this is going to be working, because the only thing we need to do is wait. Is pulling what is already there, because some of the steps are already on hub.docker.com. It doesn't need to rebuild them, it just needs to download them. Well, in the meantime, let me get the service. This is a really stressful moment for me. Actually, I don't know if you are going to hear this. Not doing anything. Oh, okay. Because it's on the HDMI? No, it's here. Okay.
Hi, Kubernets from Milano. It's 9 p.m. Woman face palming.
Okay. So it worked.
Hi, Kubernets from
Shut up.
Milano.
Okay. So the continuous deployment worked. You see, the only thing we did was a push. Usually, in real life situations, you are going to create a pull request. In the pull request, the continuous integration is going to be run. And then when you merge to master, is at the moment that you do this continuous deployment, okay? Present, in case you want to take a photo, or maybe it's going to be in the video or something, this is the repo I use. The steps are more or less explained there. And yeah. And I can't finish without saying that we are hiring in sunny Spain. I am working remotely here, but I will be moving back to Spain 15th of August. And thank you very much for coming. So any question?